Okay, so let's take a look at a couple of examples using the volume of a cylinder formula, right? So let's take a look at something like this, right? So let's say we start off with a solid cylinder and then we kind of cut out another cylinder inside, right? So here, this whole inner part is kind of empty. All right, so let's say that the outer radius, right, is, we'll call it 4 inches, and then the inner radius, we'll call it 1 inch. All right, and for this example, I want to find the volume of the solid. Okay, so if I start with my formula, right, so again, let me just write the general formula. Pi r squared times height. Oh, let me give it a height. Let's say we have a height. Here, we'll call it, say it's 8 inches. Okay, so let's say that, right, we start with, like, let's say just the bigger type cylinder that we have here, that the volume is pi 4 squared for the radius and the height being 8. Now, this quantity in itself is too large, right? Because again, we have taken something out. We've cut something out of it, right? What have we cut out? We've cut out another volume, right? And that volume is also a cylinder, right? So to find the volume, what we'll do is going to do a subtraction, right? But again, what are we subtracting? Well, we want to subtract this smaller cylinder that is really essentially a hole in the bigger one, right? So that one is pi, right, radius being 1 squared and the height still being 8. All right, so as it turns out here, right, now we just do the calculation, right? So volume, right, so what's that, 16 times 8, well, that's 64, excuse me, 128 minus 8, so we get 120 pi inches cubed. All right, don't forget the units, right? Very important, right? That we notice 120 cubic inches. Okay, all right. And again, if we're asked for a decimal approximation, we can always just plug in pi in our calculator, and pi. So that's about 300. And actually, let me use the approximation, since I will be rounding, right? As soon as you cut off any decimals, what you have is a rounding value. So this will be 376. Actually, if I round to 2 decimal places, is 0.99 inches cubed. Okay, and that's how you would find the volume of a solid like that is generated like this. Okay, let's do one more example. Let's kind of change the problem up a bit. Right, so we still have a same type of solid where we have a cylinder here and we have another cylinder that's been cut out of it, right? All right, and instead what I actually know, I know that the volume is 270 pi inches cubed. Right, and I know that the height is 3 inches. And I know that the inner radius is 8 inches. All right. So what I want in this example, I want to find the value of the outer radius. All right, so here looking at our figure, and let's use a different color here. All right, so inner radius we'll define as that first one that we hit, right? Whatever we're cutting out here. And then the outer radius would be towards all the way to the H, right? And I'll call this RI for inner, and then RO for outer. Okay, now the volume of the figure itself, so I know the volume it's given to me here as a quantity, but I also have a formula for it, right? From the previous example, right, the volume was the volume of the outer solid cylinder, so pi r outer height. And I subtract the inner cylinder that has been taken out, right? So pi r inner h. So now I have a place to start, right? I have a formula that I can work with. All right. And now here I'll plug in the quantities that I know, right? I know that the volume is 270 pi, right? So I'll just replace it, right? Here I'm just substituting, right? Pi is a, excuse me, now a couple things I forgot here, squared. Okay, so pi radius squared times height. All right, so pi is a constant, so pi stays pi. Our outer is my unknown, right? That's something that I don't know, but I do know the height, right? The height is 3, so we get 3 pi r outer squared. And then minus the inner radius is 8. 8 squared is going to be 64 pi, or times 3, I should say. The height, and then pi. Okay. All right. So now I have something I can work with, right? I have one unknown in my equation. So here is just, now it just becomes an algebra problem, right? Once I've set up my problem, I have a formula that I can work with. Now I can just simply solve here. So the first step though is let me do some simplification, right? So 64 times 3, that's 192, right? And again, don't forget the pi's. Right, those are still very much part of the problem. So we get 3 pi r outer squared. Right, and this was, what I say, well, minus 192, 64 times 3, minus 192 pi. Okay, so then the next step here, I'd add 192 to pi to both sides. Remember, treat pi like if you had, like if it was a variable x, right? Like 192 pi plus 270 pi, right? We add, if you think of it like 5x plus 3x, right? You get 8x, right? The x stays x, it's not x squared in here when we add, right? It's like a like term, so it stays pi. It's not going to be like pi squared, okay? So just keep that in mind. So it's 462 pi. Is equal to 3 pi r naught squared. Okay, right, getting closer to solving it, right? The next step, I would divide both sides by 3 pi. Okay, so the pi is reduced to 1, right? On the right side here, I'll get r naught squared, r outer squared. And then 462 divided by 3 turns out to be 154. Okay. All right. So R naught, our outer squared is 154. Okay. So we get, to find our outer, we take the square root of both sides. All right, so our outer will be the square root of 154. And then this would be in terms of inches. All right, again, we're looking for the exact answer. That's the exact answer. If we want the approximation, then we plug it into our calculators. That's about 12.41 inches. And this value makes sense, right? Right, and again, units, be very careful with the units, right? Radius is a length, so it would be in inches. Okay.